Thank you. It's really good to be here. Now, am I a robot with skin or am I a real person? How far are we away from that? Seriously, no, it's really a great honor to be here today. I'm a general manager, senior director in our industrial and robotics division at Intel. I look at all things manufacturing, all things related to artificial intelligence, all things related to where robotics are going. Great presentation, Matthew. Great presentation, Dr. It was kind of interesting as I was listening to that, and you're trying to always, listen to the audience, understand where things are going, and trying to adapt a little bit about your presentation to some extent. And sometimes I've been in the edge markets, providing compute infrastructure in the telco industry, in the manufacturing industry for many, many years now. And I see wonderful technology like this. I kind of feel like I'm a little bit old in a way as I've started to look at this. But I'm going to talk a little bit about what we're doing. I'm going to be rescued. See, obviously I'm not artificial intelligence. I would have figured this out. So, the beginning, I'll let her figure it out. Anyway, while she's working out where my slides are, I'm going to talk a little bit about what we're doing in Intel, where we're going, some of the things that we're up to, some of the things that we're looking at. And, from my perspective, if I kind of start, we start with why does robotics matter? I think Dr. Who kind of brought that out. For me, I get the opportunity to speak to manufacturers every day. I'm building an ecosystem based upon the Intel technologies. I've been providing platforms into the industrial markets for many years. Dr. Who just mentioned about some of the work that Intel have done in the IPC business over the last few years. Look, Intel's going through many challenges right now. We can all see that. You're all very aware of some of the stuff that's going on out there in the press. But I can tell you industrial and the edge markets and edge compute is key to us. It's key that we're listening to those customers, understanding those challenges. You talked about labor challenges. I hear that every day. Skills in manufacturing. We're starting to see changes in manufacturing coming out. I think we're all very aware of this word that's coming out now called tariff wars, trade wars. Manufacturing is changing globally. As we're starting to see that manufacturing realign, it's becoming geopolitical. It's becoming intrinsic to the importance of an economy. You talked about the economy here in terms of the chip industry. We're starting to see manufacturing change. So there's a great opportunity right now. We're seeing the robotics market grow. We're going to see manufacturing change. Even when we start to change governments and things change, we're going to see things, I think, intrinsically go around, and it's going to be a great opportunity for us in manufacturing and in robotics. What I'm looking at is really around this evolution. We've seen the robotics, we talked about it, where they're fixed function robots, as we talked about, AMRs into cobots, into humanoid robotics, gaining more and more collaboration. I was actually kind of very interested as I'm speaking to people, trying to figure out what is the definition of a humanoid robotic. And I've asked 10 different people and I've got 10 different answers. So the obvious one to me is something that looks like a humanoid. But when I go and talk to customers now, they're saying an AMR mixed with a fixed function robot becomes a humanoid robot or something akin to that. So the robot journey that we're going on, the opportunity there in terms of what we're doing, we're looking at the platforms that we're trying to build into that market. And for me, it's about building on foundations. You know, and I always stop here and I recite a story, and I think you saw this story yesterday, but I think it's appropriate. I've been in this industry for over 20 years. I was involved in artificial intelligence in my career many places, and I worked in South Africa many years ago in the telco industry. And we were using data at that time that was coming off of the machines to abstract information, which we were then using to reconfigure the network, optimize it for improvements in performance, trying to make it better for end users. Everything that you talked about, Matthew, making it better, making it faster, making it improve it. Now, on this particular occasion, we did this work on the network, and the network went down. So we lost a complete cellular network for almost 2 days. Now, I won't go into all the details about how we fixed it, etc. We recovered that. The story is really what happened about 6 weeks later. I had an opportunity to be on live television, South African Broadcasting Company. And I've been prepared. You can imagine if you're on live television, you've got this script in your head, you've researched the questions, they told you what they're going to ask you. I mean, it's almost like verbatim in your head. The first question comes out. Mr. Watts, welcome. Great for you to be here. 6 weeks ago, you and your team were involved in doing some work on the network. The network went off. You do realize 11 people died because they couldn't make a telephone call to emergency services. And how do you react? Now, the message isn't how I reacted, but the intrinsic what it left with me. And when we talk about technology and what it does, we must understand those foundations. So when us in Intel were looking at this, we want to make sure that as we introduce artificial intelligence, as more and more robots come in, have we built the foundations in our silicon platforms in Intel to make sure that that technology, when it's delivered, gives the right experiences? It's not just about being safe. It's about understanding what technology can do. And I've been providing those platforms for years into this business. So we are very much building that foundation. We obviously are very aware of other competition. You talk a lot about NVIDIA. We know that they're very strong in this market. Industrial PCs from Intel are running today's factories. They are out there, the IPC platform. You'll see it everywhere you go around the show, IPC platforms. As we evolve that technology, as we bring that technology through and add in new capabilities in silicon, we want to make sure that it's built solidly around the foundations so that as we bring in and implement those models that you talked about, they're going to get implemented on compute platforms in environments. People are going to be there. And even if you've got lights out manufacturing in some instances, there's still an implication of what that factory is doing. We need to be assured that the outcomes of the machines and what we're designing and the way that we're delivering technology get delivered in a safe, secure manner. We talk about opening technology, AI coming in with 5G architectures, new technologies coming everywhere. That's exposing real estate in many different areas to different types of problems that we, as an industry, need to be working on. So again, for us in Intel, it's bringing that next generation architecture, bringing it together, unifying it, bringing new technologies such as real-time determinism. You talked about that from a modeling perspective. Intel's been developing TSN, real-time technologies on its silicon. So be they in small form factor devices, core architectures, up to Xeon architectures. When you implement that technology and AI is implementing a decision, and there's a time-based decision, is that uniformity being able to deliver through that platform? Are we doing it from platform to platform across a manufacturing environment where TCC, our technology for compute sharing, comes in that environment? So again, unifying the architecture, making sure it's deterministic, built on those safe and secure value pillars that I mentioned. We also want to make it very flexible. We understand that there are many different use cases. Again, it was great to see what Matthew talked about, and I know Yamaguchi-san is going to talk about some of this stuff going forward. This compute architecture, so as we bring new CPU technology, which is faster, more efficient, more capable of running things, new NPUs that are coming through, integrated with that, up to 100, 200, 600 TOPS, as they call it, and then integrating new GPU instruction sets. So NPU, GPU, CPU coming together. Flexibly bringing that together, enabling it through the standards, making sure we build it on that sound foundation, but then use cases coming on top of that. And what I was really looking for from Intrinsic is when those models start to get deployed, they're picking up this technology. You know, I'm speaking to a manufacturer, they make things. You know, they're not technology companies. They're responsible for making the products that come out of those factories. So when we implement that, we need to be working with them very closely. Is that manufacturing consistent? Is it built on sound principle? Is the technology right? Is it flexible to bring in the new platforms for them? I'm also very keen on this subject. I suppose I could spend all afternoon talking about this, but they only give me 25 minutes, so I'll get a hook at some stage. Technology is wonderful. I'm a technologist. I love it. I love toys. I love playing with things. I love technology. Manufacturers are responsible for manufacturing. We need to make sure technology is driven around business value. Is it solving business problems? And I think this is really key. And again, I love stories. They're what make us who we are. We learn from these experiences. I was working on an oil compute platform in the middle of the Gulf of Mexico, Gulf of America, whatever your choice of that is. But I was out there on a platform working with the engineer who ran that platform. He was responsible for the control infrastructure. And I'm excited. I'm there. I've got all this technology. I've got all this knowledge to offer. I said, well, what's your problem, Alex? Alex was the guy who ran the platform. He said, well, I have an engineer. He has to go every hour around, and he's got a book, and he looks at the valves, and he looks at the meter, and he writes a number in a book, and he takes it back to the control room. I mean, this is a very dangerous environment. Safety is number one. And he says, wow, I'm a bit worried. This guy gets a bit tired. Does he write the right number down? Is this a problem? Can you help me solve this problem? I'm like, wow, this is fantastic. We can digitize this. We can take the valves out. We can do this. We can put this new infrastructure. Alex goes, whoa, stop. I said, what do you mean? I'm helping you solve your problem. He said, I was thinking you could just point a camera at the meter so that we could read it from the control room. And it was just this realization that we need to align what we do with the right value propositions as well. So I want to implement the best of technology, whether it's solving labor shortages, skills, safety, but let's align it. He reminded me that if I did what I wanted to do in that platform, it would have meant that the site had to go down. He would have lost about $50 million of revenue for a relatively small cost in terms of what it would have gained at the long term. So again, we're very keen at making sure when we bring that platform through, we're understanding the architectures. And, you know, our platforms in Intel are running these machines right now. So I want to make sure as we work with the industry, as we collaborate with you, as we bring this technology through, and you develop all of these wonderful things that we're doing, we're aligning with business value built on those sound principles. I'm not going to spend too much on these use cases. I mean, Dr. Who mentioned it as well. Go around the show. There are so many fantastic examples of robotic use cases right now. I mean, it really is an exciting time to be in the industry. I found it incredibly innovating just being here, going around and looking at what's going on in the industry. And it's going to be a fantastic industry. There's no doubt about that. It's trillions of dollars that's going to be there. I believe there's a great opportunity, particularly here in Taiwan, where you see so much innovation, so much technology, bringing that collectively together with that East meets West mentality, I think is a great opportunity. And I am very keen on stressing a point up there, which is when we develop that compute architecture for delivering artificial intelligence with robotics, with new improvements to technology in terms of connectivity, etc., I want to make sure that it aligns with cloud. Absolutely, cloud is important. 100%. If you're doing learning or digital twins, as has been mentioned here in the previous presentations, that is a great compute continuum that gives you great outcomes that have then got to be transferred and implemented onto the technologies that are going to run in the shop floor. And it's not just for the large car manufacturers. It's the manufacturer who makes bread. It's the manufacturer who might be mixing chemicals or making a battery. There are manufacturing extends in a massive, whether it's discrete or process. So we want to make sure that that cloud capability can get delivered in the right experience across the massive spectrum that there is in manufacturing. It needs to be a benefit for all. And I know Mr. Yamaguchi-san is going to talk a little bit about this when he comes up, so I'm not going to steal his thunder. I'm also a firm believer that those use cases are going to drive incremental benefit around sustainability. Sustainability seems to have lost a lot of its mojo lately. But for me, fundamentally, as a grandfather and as a father, it's very important that we understand that the things that we're doing and the implementations of those also offer tremendous benefit from a sustainability perspective. So as we see these algorithms improve and outputs from artificial intelligence or robotics coming in and reducing waste, absolutely critical for us. And again, we want to make sure that compute infrastructure that we're providing helps with that sustainable benefit. I'm also very keen to point out this slide, and I'll stop a little bit about this. Intel has been providing compute platforms for many years. What we fundamentally believe is to do that in an open way by supporting open standards. Absolutely critical. You're all part of the broad ecosystem that supports manufacturing and robotics. And we want to make sure that that's done in an open way, no walled gardens. If you provide an open infrastructure, when we develop our silicon and we enable that silicon for you, we want to show you what we can do with some of the recipes, which we're doing, some of the software assets that we're putting, but we want to make sure that those software assets are open and accessible to you. An open ecosystem promotes innovation. It means we can all participate and we can all add in value. It's absolutely fundamental to Intel's value. So we work in standards. I certainly am working in process standards, open process automation. I'm working in safety standards, 62443. How those safety standards are being extended into the world of robotics. How digital twins and some of the work that we're doing there, how is that going to come in? What does it look like from a security perspective, 62443 compliance? So we work in those standards. We want to implement the technology so that when you deploy these new models in artificial intelligence, you know that what underlies that is an open ecosystem that's supported and built on fundamentals that mean when you deliver that experience, you have the assurance that that's going to be done reliably, safe, and secure. So that openness, what we promote in Intel, is intrinsic to what we are trying to do and the way that we are approaching the industry. Some more real-world examples. There are many places where Intel technologies are already being used. We showed a few of them yesterday at a workshop that we held locally. You know, it's not often recognized. A lot of people think right now of Intel when it comes to the world of robotics and artificial intelligence. And yet, actually, I was at the HMI show, which is Hannover Messe, last year. It's the world's, I think, largest industrial show. And I do what I call a Wizard of Oz test. You know, the Wizard of Oz, if you've seen the movie, the big bad wizard, and you go up to the curtain and you realize what's behind the curtain. So I went round to 100 of the exhibitors at the show who were showing artificial intelligence. saying, hey, where are you running your AI right now? As often as not, the answer is, well, I don't know. Well, let's have a look behind the curtain. So we open up the bottom of the machine, of the exhibit, and there lies an Intel server running. 98% of them were running on Intel technologies. 98%. So I recognize that we're not necessarily the tip of the tongue right now when it comes to AI. But our machines are out there. We're developing and upgrading those machines, as I mentioned. We have our new Panther Lake platform that's coming out in the next few weeks. It's going to be launched formally at CES next year, built on our 18A technology, which you would have read about in the press. New compute capability, more improvements in AI. What's happening is, think about those platforms as we're replacing the IPC, the panel PC, the boxes that are running robots today, those fixed function robots, they're replacing them and upgrading them generally with Intel-based technology because they want to reuse the assets that they've got in software already. Yeah, they want to deploy AI, and they're focused on AI. But motion planning, motion control, a lot of that's done on Intel technologies. So now I've upgraded this platform to a new technology. If I'm a manufacturer, it's compute infrastructure that I have, and now all of a sudden we have the ability to deploy new capabilities in AI, add AI into a new robotic platform or a new manufacturing platform. You're doing it from an install base that's out there in an open way, built on those foundations, because those platforms have been running out there. So when we look at the evolution of compute, from my perspective, it gives us a great opportunity to kind of grow in the right way through the compute platforms that are being delivered and rolled out. And I'm getting the hook over there. So, okay, software defined. You will start to see many platforms, as I mentioned on Panther Lake, coming out with these NPU, CPU, and GPU architectures. We have a software capability where you can utilize and bring those assets together in a virtualized fashion running on that platform abstracted. Industry 4.0, Dr. Hu talked about that. I spend a lot of time within the industry promoting that, whether it's through next generation control systems, how we're going to interface robotics, how we're going to bring off data, how we're going to do artificial intelligence and bring these things together. We've built that software infrastructure on top of our platforms so that if you want to run a safety asset with a motion asset, with an AI asset, you can now do that all on a single platform through an abstraction layer and deploy that model in that safe and secure way. So we absolutely firmly believe that we need software capabilities built on top of that and making it simple for the ecosystem to develop. So I think I'm almost at the end, so probably I'm not going to get the hook. So our commitment is there in Intel. We are 100% committed. We believe that the industry, the manufacturer, represents one of the greatest opportunities we will see for many, many years here in Intel. We're working within the industry. We're working with the ecosystem. We're working with you here in Taiwan, with our ODM partners, with our ecosystem partners in the software world, and with the manufacturers as well. As I say, it's important that I connect with manufacturers. I speak to Procter & Gamble, John Deere, so many of these manufacturers on a week-to-week basis. What is going on? Connecting what they're trying to do with the technologies that we're talking about today. New capabilities in robotics, new capabilities that are coming from the cloud. Bringing that together with what we're doing in Intel, making sure that when those experiences come in, we're committed, we're rolling, and we are absolutely focused on enabling that ecosystem. Our success in Intel is always through the ecosystem and the collaboration that we create. And that's foundational to what we do. So, in final, before I hand over to the next person, if there's an opportunity and you want to contact me or any of the team from Intel, please do. We are 100% behind this industry. We're so excited to be involved in what's going on. We've got a lot of work to do in Intel. We're catching up in terms of some of the things that we're falling behind. And we look forward to collaborating with you, continuing the work that we've done in the ecosystem and building that momentum going forward. With that, I'd like to say thank you so much to Tyra, for the opportunity to speak and come here. First time at this show for me in person, many times, of course, in Taiwan. So, and I will continue to come here and support Taiwan, the industry, and I hope to be a very positive influence in terms of the growth that you're looking for in robotics in Taiwan and globally. Thank you.